Hey guys, today we're learning trigonometry. Now, trigonometry is the study of triangles, but today we're specifically covering sine, cosine, and tangent, or sine, cos, tan. Okay? Now, each of these sine, cos, and tan will show us something about the triangle. Now, there's four variables that we need to keep track of. The first one is theta, which is the angle that we're concerned about. The second is h, the hypotenuse, which is the longest angle, and it's away from the right angle. And then we have opposite, which is as far, the one that's furthest away from theta, or on the opposite side of the triangle from it. And then we have adjacent, which is the one that's not the hypotenuse, that is next to theta. First, we're going to take a look at the sine function and what we can do with that. Now, each of those we looked at before, they will only use 3 variables in each, even though we have 4 overall. Now, sine is concerned with the theta, hypotenuse, and opposite. So we can go ahead and get rid of the adjacent because we're not going to be using that. Now, there's a general function we can look at when we're doing operations with sine. So that formula looks like this. We start with sine, and then there's going to be some brackets, and then we're going to put theta in those brackets. We're going to write equals opposite over hypotenuse. Now this function really can't give us an answer, can it? We want to know the angle, we want to know the opposite, or we want to know the hypotenuse. Those are the 3 things that we can try to work out. And this function as it is won't let us see anything. So we have to do some rearranging in order to figure out our opposite, hypotenuse, or theta. Now we're going to start with the simplest, which is theta, which you'll be finding a lot of. So we'll start over here with our function as it is, because you will have to remember this. This is very useful. So let's go sine theta equals opposite over hypotenuse. And now to find theta, we're going to do what's called an inverse. We're going to remove the sine from here and just leave behind the theta so that we can have it equaling something and move the sine over here. Now to do that, we're going to inverse the sine, and so that will make this sine disappear here, and we will be left with theta. And on the right hand side of the equation, it's going to look like this. Sine, but there's going to be a negative 1 because it's an inverse, and then we're going to put in brackets opposite over hypotenuse, or O over H. So this is how we'll work out theta. So if we were to do an example here where we didn't know theta but we knew opposite and hypotenuse, let's say that the opposite is 5 and the hypotenuse is 11. Now this is the opposite because it's away. It's the furthest away. It's on the opposite side of theta. And this is the hypotenuse because it's the longest angle. And it's opposite from the right angle. Now, I'm going to use a calculator and I'm just going to write the answer down because I cannot do inverse sine in my head. Neither can you. Probably no one can. Which is roughly 27 degrees. Now, if your calculator gets different, I recommend changing it from rad to degrees. You need to search up how to do that. I'm not going to explain it in this video. Everyone's calculator is different. But anyway, that's how you find theta. Now we're going to take a look at how we find the hypotenuse, which is a little bit easier. So first we're going to start with our formula, as we always do. Sine theta equals opposite over hypotenuse, right? So this time we're trying to find the hypotenuse. So what we're going to do is we're going to divide both sides by the opposite. So we're going to have sine theta over opposite. Now that's not a 0. Obviously, if you divide by 0, it'd be undefined. And that equals now 1 over hypotenuse. But that's not no hypotenuse, is it? So we got to take one more step, and we're going to inverse everything. So basically, we're going to flip the division. okay? So what that's going to look like is opposite over sine theta is equal to hypotenuse. So now that is how we work out the hypotenuse. So let's try an example now where our degrees is 30, our opposite is 5, and our hypotenuse is the variable that we are trying to find. So when we plug that in, we get h is equal to, oh, and when I say plug that in, I mean use this formula, change this opposite to the 5 here, change the theta to the 30 here, and then you'll just plug that into your calculator, okay? And you get 10. Okay, so next we're going to take a look at solving for opposite, which I promise is actually the easiest to solve for. So once again, we're going to start with our trusty formula. Sine theta is equal to opposite over hypotenuse. Now, this one we do in one step. We times both sides by hypotenuse. So it's simply going to be hypotenuse times sine theta equals opposite. So that's not a 0, it's opposite. Please don't make that mistake of thinking when you write down the opposite that it's 0, and then you're going to get the wrong answer. So in this one, we're going to plug in our numbers again. Now this time we're looking for opposite. So in this question, say we had the hypotenuse as 5. Now opposite is what we're looking for, right? So now we plug that in, and we're going to get opposite equals 2.5. Now that's been it for sine. If you've watched that, that is all you need to know, okay? So whether you have the opposite that you need, the hypotenuse that you need, or the theta that you need, or the angle, you can use sine to work it out if you have the theta, opposite, and hypotenuse, okay? Now we're going to take a look at cos, and cos is what you use if you have the hypotenuse, theta, and the adjacent. So when using that, you don't have the opposite, okay? So our formula when we use cos, which is when we have the theta, adjacent, and hypotenuse, or we're trying to figure out one of them and we have two of them, is going to be cos theta equals A over H. Now, for those of you who are paying a lot of attention, you might realize that this formula is very similar to the sine formula, okay? Now, the differences are that instead of sine, we have cos, and instead of the O over H, we now have A over H, so adjacent over hypotenuse. And that's the only difference. So all of these questions are going to be solved the exact same way now. So we're going to start with cos theta equals adjacent over hypotenuse. So we're going to do the same thing where we inverse the sine, and we'll be left with theta equals cos -1. So this time instead of inverse sine, it's inverse cos. And then we're just going to have A, and this time we're just going to have A over H, so adjacent over hypotenuse. And it's that simple. So let's try an example where the hypotenuse is 10 and the adjacent, so the one that's not the hypotenuse, that is next to the theta, so not this one, the one that's next to it, but not the hypotenuse, is 5. Now when we plug this in, so we put 5 as the adjacent and 10 as the hypotenuse, then we get cos -1, 60 degrees, okay? Right, so now we're going to take a look at finding the hypotenuse again, and it's going to be the exact same as when we did sine. So we're going to start with our trusty formula. which I hope you remember by now. It's pretty much the same for everyone, just a little bit's changed each time. So we're finding hypotenuse. So the first step we're going to take, we want to isolate the h by itself. So we're going to divide both sides by a to get it off of this side. Now this hypotenuse, it's on the bottom of the fraction, so we're going to inverse both sides, basically flip the fraction, and then we'll get hypotenuse is equal to a over cos theta. So in this example, we're going to have the theta as 30. We're going to have the adjacent angle as, or adjacent side, sorry, as a length of 10. And hypotenuse is what we're working out. So h equals, and we'll just plug the adjacent into here and the theta into here, and we get an answer of 20. Okay? Now don't forget when you're doing these questions, if you have some kind of unit of measurement that's attached to your lengths, you really need to be writing that at this point. Okay? So if this was 10 meters, this would be 20 meters. If this was 10 centimeters, this would be 20 centimeters. Okay? Don't forget that, please. And now lastly, we'll be trying to find the adjacent, which is by far the easiest. Same way we did it with sine, except we were finding the opposite. Let's go. We're simply going to multiply both sides by the hypotenuse so that we can eliminate it from this side and isolate the a or the adjacent and have that as our answer. So h times cos theta equals a. Now we can plug this into our calculator. Now in this question, we're going to have a hypotenuse of 10. And obviously our adjacent, we don't know. That's what we're trying to work out. And we plug it in. So we'll be putting the 30 into here and the 10 into here. And we get that a is equal to 8.66. And now that's it for cos. That's all you really need to know. Now we're going to move on to tan, which is kind of the most different to all three of the trigonometric equations, but it's still set out exactly the same as this. So let's take a look. Now that I've written it out, you can see it here. It's simply the same. A function, theta equals something over something. And this time it's tan and opposite over adjacent. So working out all of these theta opposite adjacent is going to be the same as working out the theta opposite and hypotenuse or adjacent in the other questions, okay? So first one we've been doing, we'll start with theta. So let's take a look here. Write out our trusty equation. Tan theta equals opposite over adjacent. Now all we're going to do is we're going to inverse the tan. So we'll be left with theta on this side equals tan inverse opposite over adjacent. And you remember it's opposite over adjacent because SOHCAHTOA ends in TOA. I'm going to explain SOHCAHTOA at the end of the video. Please keep watching if you want to see that. It's a very easy way to remember how each of these is set out, okay? Now for this question, opposite, which is the one opposite from theta, will be equal to 5. And we're going to have the adjacent length be the same of 5. And now we would plug 5 above here and 5 down there. So the adjacent is 5 and the opposite is 5. And we get theta is equal to 45 degrees. Okay? So pretty simple. Now let's move on to finding the adjacent. Now for this one, we're going to start with our trusty equation again. I'm going to go and take the opposite away so that we're just isolating the a and we can find that. So tan theta over O equals 1 over a. And now like before, we're going to flip the fractions or inverse them and we get O over tan theta is equal to a. Now in this question, we're going to have the theta be equal to 30, and we're going to have the opposite be equal to 4. Okay, so now we're going to plug the 30 into here and the 4 into here on the O, and we get that A is equal to is 2.31. And lastly, we're going to do an example where we find the opposite, okay? Now this one's the easiest because all we're going to have to do is multiply both sides by A, and that leaves us with A times tan theta is equal to O. And in this example, our adjacent angle is 6, so we'll put that here, and our theta or our angle is 30, so we put that there. And that leaves us with the opposite is equal to 3.15. And that is it. That is how you work out the opposite, hypotenuse, adjacent sides, or theta, given that you have only 2 of any of the other variables, okay? So now, let's go ahead and talk about what SOHCAHTOA is. So let me write it out for you. Now, seriously, I highly recommend remembering this. It is so useful when you're doing trigonometry. Now, let's take a look at it. So, SOHCAHTOA. There are actually 3 distinct sections in this word. First, we have SOH, then we have KA, and then we have TOA. Now we have sine, cos, and tan. SOH is sine equals opposite over hypotenuse. Cos is equal to adjacent over hypotenuse. And TOA means tan is equal to opposite over adjacent. Now you just got to say it a bunch of times and it'll make sense. SOHCAHTOA. SOHCAHTOA. And now, whenever you use sine, you're going to remember SOH. Whenever you use cos, you're going to remember KA. And whenever you use TOA, you're going to remember. And whenever you use tan, you're going to remember TOA. So, it's pretty good to remember. I love it. Now, if you want more videos on trigonometry, please let me know in the comments below. I can cover in-depth solving questions with anything to do with trigonometry. You just let me know. And if you enjoyed this video or learned anything, please like, and I'll see you guys in the next video. Thanks for watching.